Hi, welcome to the class. Today we start another topic of chapter current electricity, and the name of the topic is potentiometer, right? So, like the previous device which we did was the Wheatstone bridge. In that, what we studied and the sequence of our study was first we introduce the device, like what the potentiometer is. So, potentiometer is a device which is used to measure the potential of a cell without drawing the current from the cell, right? So what does it mean? So the potential or the voltage of a cell can be measured by using voltmeter, right? But voltmeter takes current for its function from the cell itself, whereas potentiometer does not draw any current from the cell. So when it does not draw any current from the cell, basically it measures the EMF of the cell. You getting what I'm saying? Because we understood that EMF is the maximum potential of a cell when no current is drawn from it. So basically when potentiometer does not draw any current from the cell, it measures the EMF of the cell. Whereas the voltmeter measures the potential of the cell because it draws the current from the cell. So that is the major difference, and that is the advantage of using potentiometer, right? So potentiometer. So this potentiometer measures the EMF and the voltmeter measures the potential, right? So that is why this is the biggest advantage of potentiometer, that it measures the EMF and that it does by not drawing any current from the cell, whereas voltmeter measures the potential difference and it draws current from the cell. So that was the introduction part. Now what is the principle on which it works? It works on the principle that whenever potential drop takes place, so suppose this is a wire, right? So whenever any potential drop that takes place, potential drop, I'm talking about the potential drop. So EMF is there, EMF is there when no current is drawn, right? So potential, this is the term, this is the potential difference. So drop will take place when the current will pass and when there is a resistance. Drop will take place when current will pass and there is a resistance. So V is equals to IR. This is the drop. Drop in what? Drop in the EMF. Potential drop. And whatever is left after subtracting voltage drop from the EMF is what we call terminal potential. Terminal potential, right? So this drop depends on current, when the current flows, and the resistance. And further, this resistance, we know that it is directly proportional to length. Resistance is directly proportional to length, right? So this drop or the fall in potential, is directly proportional to the length. Why it is directly proportional to the length? Because resistance is directly proportional to L. And when this length will increase, resistance will increase. When resistance will increase, this potential drop or the fall in the potential will increase. So this is the very important point, that this fall, which is V potential, is directly proportional to L, right? If you remove this proportionality, K comes constant, K is a constant, and its name is potential gradient. Potential gradient. Potential gradient. So if you take the formula for potential gradient, it will be K is equals to V upon L. V is the volt and L is the length, which is in meter. So K is volt per meter. So as you can see that K is inversely proportional to L. Right? So more the length, less will be K if V is constant. So that is the case here. So that was about the principle. Now description and diagram. So this is the diagram. So in the diagram you can see we have a battery, a rheostat, a key, and then we have a galvanometer and a jockey. And there is a wire placed on a wooden scale, and the wire is of 100 centimeter. The length of this wire is 100 centimeter. This part will be more clear when I do the experiment with you. So the wire is 100 centimeter and the wire is made up of manganese and constant term. The wire is made up of manganese and constant term, right? So the wire is made up of an alloy. So that was the description in the diagram. Now, as I told you, this potentiometer has an advantage over voltmeter that it measures the EMF. It does not draw any current from the cell. Whereas the voltmeter draws current from the cell and therefore it measures the potential. It measures the potential of the cell. So this is the difference between potentiometer and voltmeter, and this is the advantage of potentiometer over voltmeter, right? Now what are the uses of this potentiometer? So uses of the potentiometer is to compare the EMF of two cells. So if you have two cells and you want to compare the EMFs of the two cells, first you calculate the EMF of one cell, then you calculate the EMF of the other cell, and then you compare them. You take out the ratio. So that also we will do. Experimentally we will do. So comparison of EMF of two cells would be our next topic. So that was the introduction, right? Thank you.